Graph by using the intercepts. And when these are already presented to you in standard form like number 1, it's awesome. When it's presented to you in this form, slope-intercept form, it's still awesome, but not quite as awesome. So if I'm looking at number 1, I'm going to go ahead and set this up. I'm rewriting 3x plus 2y equals 9. And if you were to look back in your notes, you'd see that where the x-intercept is, that was where the y value was 0. And when we map this out, I'd like to see this worked out neatly. So put x-int, and then after that, parentheses, make a note y is 0. You're going to be reminding yourself that that is the case. This is going to help you maybe memorize it easier. And then on the other side, in dealing with the y-intercept, jumping back to your notes, that was where x was 0, because it's where we're intercepting the x-axis. And then likewise, we're going to put parentheses. So it's the opposite for these. So the x-intercept is where y is 0, and the y-intercept is where x is 0. Maybe that's counterintuitive, I'm not sure. But if I look at the original equation and rewrite it below here, here's 3x plus 2y equals 9, and I'm going to plug in a value of 0 for y. So here's 2 times 0 equals 9. Now what's cool about this is the 2 times 0 term, the y term, drops out, and you're left with 3x equals 9, which you're going to then divide by 3, and get x is equal to 3. The y-intercept, where x is 0, is going to be 3x plus 2y equals 9. And if you're like, oh man, I could be jumping into these right away, good for you. I just want you to show the work on this first one. So 3 times 0 plus 2y equals 9, which means that 2y equals 9, and dividing by 2, y will be 9 halves. And when I see 9 halves, I'm thinking of 4.5 there. And we're not done with this. And the reason we're not done is because we're told to graph using these intercepts. I'd like you to do this to the right side, but I'm running out of room. So here I am with a couple positive intercepts, so maybe I'll make this. Just, your typical symmetric with the first, second, third, and fourth quadrants. So here's me 5 over 1, 2, 3, 4. And here I am 5 up 1, 2, 3, 4. And so when I drop the x-intercept down first, I'm going to have a value that is actually 3 over at 0. So if I wanted to think of this as a coordinate, it's 3, 0. I should use a different color. There's 3, 0. Now, because the y-intercept, which we'll do next, is where x is 0, we solved it to figure out that it's 9 halves. And when I see 9 halves, I'm just picturing 4.5. So I'm going to be right there in the middle of 4 and 5. And then I'm turning my iPad that I'm doing this on. But you're getting a ruler out, because what I'm doing is a little bit stranger. And then we'll label this. We'll label this with the original equation. 3x plus 2y equals 9. Okay, now let's look back at this problem. We were told to use the x and the y-intercepts. We mapped it out by doing the x on the left, the y on the right. We clearly labeled that y is 0 and that x is 0 to help coach us through this. We thought about it as ordered pairs once we got to the end. just as a way to kind of graph it easier. But really, as you get into these, what you'll end up doing in your head, maybe you'll just jump straight to the graph, and you'll be like, well, my x-intercept is y is 0, so that's gone. And the only thing times 3 that'll give me 9 is 3. Then you graph it. Then you go to your other one, and you're like, well, 2 times, what's that have to be? Well, 4.5. And you're literally done that quickly. Okay, so that we're getting the second problem the way we like to do these, let's go and rewrite it first of all. So I'm going to scribble through that since we're finished with that. 2 has y equals negative x minus 5. For the x-intercept, one more time, that's where y is 0. For the y-intercept, just talked about it. Write it. X is 0. So, if I'm going to plug in 0, maybe you're okay jumping. You just say, well, 0 is going to be equal to negative x minus 5. And if you can look at this and realize that the answer has to be negative 5, great. If not, I'd say solve it to get the x by itself. That way you can see that x would be negative 5. You could solve it a different way if you wanted. And then on the other side we got y equals negative 0 minus 5, which means that y has to be negative 5. I'd like your work to be a little bit neater than mine, but I'd like you to see this whole thing in one window. So here's my x and y axes, and I have values at negative 5 for x, negative 5 for y, and the cool thing about that is, you kind of don't even need tick marks for it. Make sure that your line more clearly goes through it than mine does, and then we label it in the original form they gave us, which is y equals negative x minus 5. And since the graph is our answer, that's our answer. And I can map this work and figure it out really cleanly. Here's the other thing. If you do not go through the nice steps of clearly showing the x and the y-intercept work, then your graph needs to be crazy neat. Because if there's any confusion in the presentation of it, then it's just sloppy, and somebody shouldn't take your word for it. So yeah, that's graphing those problems using x and y-intercepts.